Okay, this is Mr. Peterson. We're on Math 31, Section 3.2. And in this section, we're going to learn how to solve equations using addition and multiplication. This is a review of some of the concepts we've had before. And later on, you're going to look at how to translate from English phrases to mathematical phrases. Okay, example A here, we have to simplify the left-hand side. 14y minus 9y would be 5y. And then we have to counteract the multiplying by 5 when it says 5y by dividing by 5y. I'm sorry, by dividing by 5. And we end up with y equals 8. 40 divided by 5 is 8. So the value of y in this problem is just 8. Example B adds another step to it. We're going to have to simplify the left-hand side and the right-hand side separately. We have like terms. So you may notice that both of these terms have m in them. And when you combine them, you get negative 3m. Combining the like terms on the other side, negative 2 plus 23 is 21. So now we're going to undo the multiplying by negative 3 by dividing by negative 3. And after that cancels, you get m equals negative 7. Okay, on example C, we'll simplify the left-hand side. 17 minus 29 is negative 12. And to counteract division, you want to multiply. So multiply by negative 2 on both sides. And that takes us to 24 on the left-hand side. And after these negative 2's cancel, you just get the t. So now we know the value of t, 24. On example D, we have on the left-hand side a situation where we have to distribute. Okay, and this is the first example of this sort of a problem. We're going to have to gather like terms. I'm going to do that by bringing all the x's to the left and all the other terms, the constants, to the right. And those two that we're moving have to change signs. So I'm going to have my 6x that's already over there, but that 7x when it joins is going to become negative 7x. And the negative 3 was already on the right, but the minus 8 becomes plus 8. And the effect really is that we're adding 8 to both sides. The left-hand side simplifies to this, and the right-hand side simplifies to 5. Dividing both sides by negative 1 gives our answer of negative 5. Okay, we're going to find C in this example E here. And it looks like we're going to have to take that 5 over to join its like term, its partner over there. Negative 14 is joined by the constant positive 5 here. Remember, when you take something from one side to the other, you have to change the sign. So that gives 3c on the left and negative 9 on the right. Dividing by 3 here will finish the job for us. We end up with c equals negative 3. Okay, the rest of this exercise is all about translating phrases, and so I'm going to try and organize it a little bit here for you and group the problems by type. This section involves multiplication and addition. I've highlighted the addition in yellow and the multiplication in blue. The sum of 3 times a number and 4. Sum means addition. And in front we have 3 times the number and 4 added to it. So that one's done. Okay, in example G, the plus indicates addition. And so we're adding 5 times the number, negative 5 times the number, and 19. Okay, on H, it says negative 5 times the sum of a number and 6. Well, the sum of a number and 6 would be just that. And we're supposed to take negative 5 times all of that. So this is a case where you have to have parentheses around it because it's negative 5 times. It doesn't say negative 5 times the number. It says negative 5 5 times the sum of the number. So you need parentheses around that sum. Okay, the next two involve addition also, but it's reversed. And by that I mean whatever's mentioned in front of the more than has to show up behind it when you do it right. So 2 more than the product of 6 and a number. So the product of 6 and a number would be that. Likewise, J, when it says added to, you're going to put a plus sign, but the 13 better follow instead. This is a reversed addition. The product of 9 and a number. Product means multiply. Okay, here is subtraction, and the two that I'm going over here in yellow are difference and decreased by. They're both subtraction. The difference of twice the number, that means 2 times x, and 6. Okay, negative 4 times a number. Let me write that. Decreased by negative 5. All right, example M, 4 times the difference of triple a number and 6. Well, triple a number and 6, when you put the difference there, it's a subtraction, like this. It says triple a number and 3, and we're supposed to take 4 times that difference. That's the difference of triple a number and 3, and we're supposed to take 4 times that difference. Parentheses are needed in that problem. Okay, these are very important. It's a source of lots of mistakes. Reverse subtraction. Less than is a subtraction, but whatever is mentioned in front of it has to follow when you put it on paper. So 7 less than triple the number. Negative 9 subtracted from, this is also a reversed subtraction. So the negative 9 has to be behind the subtraction. And the product of 2 and a number looks like that. I could say twice a number instead of the product of 2 and a number. Okay, we have 2 more problems here, and these involve division. Now, if you divide with the old style, I'm going to encourage you that in algebra we do it with a fraction bar instead. So both of those are quotients. A divided by B with the old style symbol, and it's much preferable to use the fraction bar, so I will only be using that fraction bar. All right, 5 more than the quotient, so let me start out with the 5 more than. Notice that it's reversed again. The quotient of 10 and a number. Okay, the quotient of twice a number and negative 3. Here's twice a number, quotient, negative 3. And then decreased by 10. And that does it for section 3.2 in Math 31. And I hope this helps you with your homework in this section.